Find the sum to n terms of an arithmetico-geometric series. Okay, let us begin. So here we have a series given by 1 plus 2/3 plus 3 over 3 squared plus 4 over 3 cube and so on. Now this series is not a arithmetic series because it does not have a common difference. Also, it is not a geometric series because it does not have any common ratio. However, this particular series is composed of both an arithmetic as well as a geometric sequence. So our first task will be to separate the two sequences. For this, we are going to rewrite the terms. So let's say we have the first term 1, but we're going to rewrite it as 1 multiplied to 1. Added to the next term we have 2 over 3, so we're going to rewrite it as 2 multiplied to 1 over 3. Added to, now we have 3 over 3 squared, but we're going to rewrite it as 3 multiplied to 1 over 3 squared. Added to 4 over 3 cubed, so that's going to be 4 multiplied to 1 over 3 raised to the power of 4, and this is going to continue. Now here we're saying that if we consider the terms 1, 2, 3, 4, so these terms are going to be in arithmetic progression. So here this is what we have found out, and the other terms 1 over 3, 1 over 3 squared, 1 over 3 raised to the power 4. So these terms are going to be in geometric progression. That makes perfect sense because here in this arithmetic progression it has a common difference of 1, and in the geometric progression it has a common ratio 1 over 3. So here we can now define the nth term of the arithmetic progression, which has the formula a plus n minus 1 times the common difference d. A will be the first term, d will be the common difference, and n represents the number of terms. So we have 1 added to n minus 1 times the common difference with 1. So this is going to give us n. So that means the nth term is given by n. And then coming to the geometric progression, the nth term that's defined as a multiplied to the common ratio raised to the power of number of terms minus 1. When substitute the values, we're going to get 1 over 3 raised to the power of n minus 1. So we have separately obtained the nth term of the arithmetic progression as well as the geometric progression, which means that then you can say thus the nth term of the arithmetico-geometric series arithmetico-geometric series 1 plus 2/3 plus 3 over 3 squared and so on. This is going to be given by, all we have to do is take the nth term of the arithmetic progression, which is going to be n, and then to it we're going to multiply the nth term of the geometric progression, or in other words we can divide it with 3 raised to the power of n minus 1, and this is going to be the nth term of the original series, the arithmetico-geometric series. We can actually verify that this is true or not. So let us suppose that n equals to 4. That means we want to find out the fourth term of the series. So according to this formula, replace n with 4. So we have 4 divided by 3 raised to the power of 4 minus 1, which gives us 4 over 3 cube. So this is going to be the nth term of the arithmetico-geometric series. So now that we have the nth term, we are ready to find out the sum. For this, what we'll do, we're going to consider a sum. So let us suppose that Sn represents the sum to n term. So here this is going to be equals to 1 plus 2 over 3 added to 3 over 3 squared added to 4 over 3 cube, and this goes all the way up to the nth term given by n over 3 raised to the power of n minus 1. However, we're also going to consider the previous term of the last term, or can say the second last term. To find out the second last term, all we have to do is replace the n value with n minus 1 in the last term or in the nth term. So that's going to give us n minus 1 divided by 3 raised to the power of n minus 2. Next, what we'll do, we are going to take Sn when we are going to multiply each terms of Sn with the common ratio. So we obtain the common ratio as 1 over 3 for the geometric progression. So we take the common ratio of the geometric progression, which is 1 over 3, and multiply to each of the terms of Sn. So 1 multiplied to 1/3, that's going to give us 1 over 3. Added to 2 over 3 multiplied to 1 over 3, so that's going to give us 2 over 3 squared. Added to 3 over 3 squared multiplied to 1 over 3, so that will be 3 over 3 cube. And this is going to continue all the way up to the second last term. So we have n minus 1 divided by 3 raised to the power of n minus 2, but we are multiplying it with 1 over 3, so that's going to make it 3 raised to the power of n minus 1. Added to n divided by 3 raised to the power of n. So this one done so that we can now subtract 1/3 of Sn from Sn. That means Sn minus 1/3 of Sn. This is going to give us the first term that's going to stay as 1. Then we have 2/3 minus 1/3, so that will be 1/3. Added to 3/3 squared minus 2/3 squared, so that's going to be 1/3 squared. Added to 4/3 cube minus 3/3 cube, so that's 1/3 cube. So this keeps on going. Now we're going to reach the last term of Sn, and from it subtract the second last term of 1/3 of Sn. So that's going to leave us with 1/3 raised to the power of n minus 1. And then we have the remaining last term of 1/3 of Sn, so that's negative n divided by 3 raised to the power of n. Okay, so this now leaves us with Sn multiplied to 1 minus 1/3 on the left hand side. This will be equals to 1 plus. Now here, from the second term to all the way up to the second last term, this is a geometric series. Now clearly here, a, which is the first term, that's given by 1/3. The common ratio, that's also 1/3. All we have to do is take any term in the series and divide it by the previous term. That gives us 1/3. And what are the, how many terms are there? So there are in total of n minus 1 number of terms. Now let's try to verify why there are n minus 1 number of terms. So while performing the subtraction from Sn, we considered the second term and went all the way up to the last term. We excluded the first term 1 here. Now since Sn contains n number of terms, the moment we exclude one of the term, it's going to leave us with only n minus 1 number of terms. Similarly, coming to 1/3 of Sn, while performing the subtraction, we considered the first term all the way up to the second last term, and here we excluded the last term. So that means here also we're going to have n minus 1 number of terms. Now, during the subtraction, we considered n minus 1 terms of Sn, and from here subtracted n minus 1 terms of 1/3 of Sn. So that's going to leave us with n minus 1 number of terms. We have n minus 1 terms, which means that the sum, and we know there's a standard formula for finding out the sum to n terms, that's given by a multiplied to 1 minus the common ratio r raised to the power of the number of terms, which is n. This is the general formula, divided by 1 minus r. So if we use this general formula, then ra, which is going to be 1/3, multiplied to 1 minus the common ratio, that is 1/3, raised to the power of n, but n here represents n minus 1, the total number of terms, whole, divided by 1 minus the common ratio, which is 1/3, minus the remaining term, n divided by 3 raised to the power of n. Now 1 minus 1/3, that's 2/3. So we have Sn multiplied to 2/3 equals to 1 added to, so here we have 1/3 divided by 1 minus 1/3, which is actually 2/3 here. So 1/3 over 2/3, that's simply going to be 1/2. So 1/2 multiplied to 1 minus 1/3 raised to the power of n minus 1 minus n divided by 3 raised to the power of n. So Sn, that's 2/3. Let's further simplify here. So we have 1 added to half times 1, that's simply going to be 1/2, minus we have 1/2 multiplied to 3 raised to the power of n minus 1 minus n over 3 raised to the power of n. Further simplification gives us 2/3 of Sn equals to, so 1 added to 1/2, that's going to be 3/2. 3/2 minus 1/2 times 3 raised to the power of n minus 1 minus n over 3 raised to the power of n. We're going to multiply throughout with 3/2. So we are going to multiply 3/2 with each terms on the right hand side as well. This is done so that we can get rid of this coefficient 2/3 of Sn, and that's going to give us the sum to n terms Sn. So we have 3/2 multiplied to 3/2, so that's going to be 9/4 minus, so we have 1 times 3, that's 3, divided by 2 times 2, that's going to be 4. 4 times 3 raised to the power of n minus 1 minus we have 3 times n divided by 2 multiplied to 3 raised to the power of n. Furthermore, we can use the law of exponents here. We have 9/4 minus, we're going to combine the 3 from the numerator at the 3 in the denominator. So that's going to give us 1 divided by 4 multiplied to 3 raised to the power of n minus 2. Minus, similarly, we can combine the 3 from the numerator with the 3 raised to the power of n in the denominator to get n divided by 2 times 3 raised to the power of n minus 1. And this is going to be the final sum of the arithmetico-geometric series.